Alrighty, we are going to tackle 7.2. And in 7.2, we're going to be learning a different way to solve for the solution of a system. Keeping in mind that our solution is still going to be a point. It's still going to be an x, y coordinate pair. So we need to be able to find both x and y. But doing it using graphing to figure out where they cross is tricky. It's hard to graph. If your lines are off a little bit, it's hard to tell where they cross. And also if your numbers are fractions, it's hard to say, do they cross at a half? Do they cross at a third? So there are some alternate methods for solving that. And so these steps right here are going to help us do this in a different manner, in a way that we call the substitution method. So in math, we like to call things exactly what they are. And so when we were doing the graphing method, it was because we were graphing. Sorry, I'm having a bad handwriting spell. And substitution is because we're going to be substituting. So these are your steps. We're going to get one equation. We need it to either be x equals something or y equals something. And we're going to do whatever one is easier. So we're going to look at the problem and we're going to choose the easiest one. And I'll show you what that means. After we know what x equals or what y equals, we're going to go ahead and substitute that in to the other equation. That's the key. And at that point, you'll just be able to solve and you will get one of your answers. You'll either get x or y. So at this point, you will get x or y. Not both, but you need both. So our last step is going to be to put that answer that we did get back into one of the other equations to find the other variable. So by the time we do these last two steps, maybe we found x, we'll plug it in to find y, or maybe we found y first and then we have to plug it back in to find x. So these steps make perfectly good sense to me because I'm a math teacher and I've done them a million times. Let's go through these steps with examples. Now, this get one equation to be y or equals or x equals, you don't always have to do that step because, for example, here in this problem, the top equation already has y equals something. So the question is, what does y equal? Well, apparently it equals 3x plus 2. Okay, so we already did that step. We didn't have to do anything. Now we're going to substitute that part into the other equation. So now we need to use this equation, and we're going to rewrite it, x plus 2, but where there used to be a y, you are going to substitute in what we learned y equals, which is 3x plus 2. And then equals 11. So I'm rewriting this bottom equation and substituting in the thing that is equal to y. Because what you need is you need one equation with one variable, meaning one letter, instead of what we had to begin with was two equations with two variables. So we need one. Now we go ahead and solve. And this again means that you need to be pretty on top of your game with the skills we already learned. So the better you were at practicing and staying on top of things earlier, the easier that's going to make everything right now. So when we solved, we had to follow some order of operations and kind of think about what to do first. And one of the things we did first was distribute if there were parentheses. Then we would combine like terms. Now I can start trying to get my x alone. I'm going to take up way too much space here, accidentally. And so when I'm all said and done here, I find out that x equals 1. So that is substituting in the part to the other equation and solving for that first part of my solution. So now I know that the x part of my equation, of my solution is going to be a 1. Now I'm going to do this very last step 4, and I'm going to put that answer back in, and I can actually choose which one of these I want to plug it into. I like to pick the easier one. It will be easier in here to find out y if I know what the x is. I can just plug into that equation the x value that I just got of 1. 3 times 1 is 3, plus 2 is 5. So this is my solution to this system. And again, I can do what we've been doing with the graphing. I could plug my x and y into those two equations to make sure that I actually have the right answers. All right, so taking a look at this next one, again, I don't have to do anything to get x or y equals because the very first problem has x equal to 2y minus 6. So in my second equation, I write 4, and then there's supposed to be an x plus 6y equals 4. But from this initial equation, anywhere there's an x, I can put what it's equal to. So I'm going to put a 2y minus 6. I'm substituting that in for what used to be this x. Because now again, I have one equation with one variable. And I start that whole solving process. I distribute. I combine these two like terms. I'm going to add my 24. So at this point, I have 14y equals 28. So dividing by 14, I get the first half of my coordinate pair. Up here, I got x first, and in this one, I got y first. So when you go to put your answers in their coordinate form, make sure that you pay attention to what you found. We found y, so it has to go in the y spot. And then to find x, I go back to my original problems and I look to see which one will be easier to plug into and get x. Well, that's going to be this top equation for sure, because it's straight up telling me x will equal 2 times whatever y is minus 6. Well, I just found a y value of 2, so I'm going to plug that in. Now x is going to equal 4 minus 6, so x is negative 2. So these two, the x equaling negative 2 and the y positive 2, that is my solution or coordinate pair that will make both of those equations true. It also means if I took the time to graph those two equations, they would cross at negative 2, positive 2. How about down here? Again, thankfully, I have y equals, so it's already equal to something. So anywhere there is a y in the next equation, I can substitute in negative 3x minus 7. So let's do that. Negative 2x plus 4, and then I'm going to substitute in for y, equals 0. I'm just copying this bottom problem, but I'm going to substitute in my negative 3x minus 7 where there used to be a y, because according to this first equation, they are the same thing. Y is equal to negative 3x minus 7. So, same as before. I'm going to distribute my 4. Here I have 2 that can combine because they're on the same side of the equal sign. Now I'm going to move that negative 28 over by addition. So I'm adding it here and I'm adding it here. So when I divide by negative 14, I find out that x is negative 2. Awesome. When I go to write my solution, that is the x, so it goes first. I look back at my problems and say, where's the easiest place to plug in my x in order to find my y? That's going to be right here, because y will equal negative 3 times whatever I have for x minus 7. I'm just copying that equation. Well, the x that I got is a negative 2. So then that would be positive 6 minus 7, so negative 1. So then that is my x, y coordinate pair for this problem that would solve the system. Last example. X equals 4y plus 19. So in the next problem where there used to be an x, I'm going to put in the thing that x is equal to, which is 4y plus 19. All right, so I'm going to do what I've been doing in every problem. I'm going to start solving by distributing. And so I'm going to have 6 times 4y, and then 6 times 19, and then I have another y equals 4. So 24y plus 1y is 25y. I need to get that 114 out of there by subtraction. So then 25y is going to equal 4 minus 114. Sorry. And so I'm going to end up with negative 110. And then when I divide by 25, I'm actually going to get a decimal. I'm getting that y equals negative 4.4. That doesn't mean that I did it wrong. It just means that, you know, I'm going to eventually get problems where it just doesn't come together as a nice, pretty whole number. Okay, so let's go ahead and take a look at how do I find the x. Well, you find the x the same way. It's just you'll be plugging in a decimal. So I go back to my original problems and I look to see which one will be easier to plug in. And that is again going to be this top one. X is going to equal 4 times whatever I got for y plus 19. Well, I got negative 4.4. So if I take 4 times negative 4.4 and then add 19, I'm going to end up with a positive 1.4. Now this might be one where I'm like, that does not seem like I did it right. I'm going to go ahead and check my answer. How do we do that? Well, we do that the same way we've been doing it in graphing and in deciding if something's a solution. I'm going to put in for all my x's 1.4 and for all my y's negative 4.4. So let's try. The first one is 1.4 because I'm plugging in an x for this equal to, so I don't know yet, 4 times my y value of negative 4.4 plus 19. I don't know. I'm going to get out my calculator. 4 times negative 4.4 and then add 19 came out to be 1.4. So that's awesome. It checks in the first of my two equations. Then let's check and make sure that it works in the second, because when you do a system, it has to work in both. So in the second problem, it's 6, and then you plug in your x, plus then you plug in your y, and that should equal 4. Well, here's my solution. So x is 1.4, I think, and y is negative 4.4. So again, bust out your calculator. 6 times 1.4 plus negative 4.4. And I got a 4, which does equal the 4 I was supposed to get. So even though I felt like my answers were kind of weird, I can always check them by plugging them in and confirm that those are indeed my solutions. So watch any part of this that you need to. Take your time, revisit the steps here. I'll get rid of my writing so you can actually see when you look back. And then go ahead and give it a try. You are not going to be able to do this without some practice. So go ahead and practice. Have a great day.